Okay. So today we're going to start looking at some effective encoding strategies, and then we're going to talk a little bit about retrieval. And then that leaves sort of the rest of retrieval and some of our errors in retrieval and how we forget things for Friday. But we'll probably get through this fairly quickly. But this whole section, at least for the beginning, is going to be asking or answering the question, how do we improve our memory? So what can we do to help make our encoding more effective so that we can recall that information in the future? And so it's always annoying that we only get to this point in the course, this far into the course, because these are going to be things that can be effective study strategies. And I kind of wish that we could do them at the beginning of the class, but we integrate it with all of the different parts of the brain and all of those other things that we need the earlier chapters to have an understanding of. So every year I'm faced with this. I wish we could cover it sooner, but this is when it falls according to what we've learned. But we're going to start by talking about how we can effectively space out our studying. And this is basically the idea of, do you study all at once or do you study periodically over a longer period of time? So the first option is studying all at once, could also be called massed practice. And that's basically cramming. So if you sit down the night before a big test and study for 2 hours, that would be a single massed practice session. If you wanted to do better at remembering that information, making it easier to recall in the future, you'd be better off using something called spaced practice, where you actually spread out your studying over multiple periods of time. And so even if you used the same overall amount of studying, even if you had, say, 2 hours total study time, but now you split it up into 4 days with a half an hour of studying each day, you'd actually do significantly better with that spaced out practice than you would on a massed practice schedule. And so this is kind of frustrating because a lot of students, we end up relying on cramming the night before a test. And that's fine for short-term recall, as we'll see in a couple of graphs a little later on. But if we want anything to stick with us longer term, it's much, much better to spread out our studying and to take much more time with it. And though we're talking about this in terms of semantic memory, so studying and remembering facts, this spacing effect is also very effective for things like remembering episodic memories, so things that have happened to you that you have personally experienced, and they're also better for procedural memories. So if you had to, learn to roller skate for a particular timeline, maybe a friend has signed you up for a fundraiser where you have to roller skate for a certain amount of time. If you wanted to learn by that period, you'd actually be better off having multiple shorter lessons that are spread out over time than having one crash course session sort of the day of the fundraiser. And that always makes me think of my sister is dating someone from Ireland, and he hasn't done any of the winter activities because they don't get a ton of snow. So he's living in Toronto now, and they get lots of snow, and he's been taken ice skating. And despite being a big, tough guy, he was like, I don't know how to do this. But they taught him eventually, having gone a couple of times. So they spread out his lessons, and now he can skate effectively. I guess as effectively as you can after just a year of exposure. But it is a more effective method. All right, the next bunch of slides are going to focus in on mnemonics and how we can effectively use these little shortcuts to help us encode and recall information. And when I was younger, I had a misconception about what mnemonics were. I assumed that it was referring to one specific technique, but mnemonics is actually a broader category that just refers to a bunch of different shortcuts that help provide a framework for us to store information and retrieve it later. So basically, we're setting up our own rules in order to study information and help us remember it at a later date. And there are tons of different kinds of mnemonics. On the slide here, we have a peg word method, keyword method, method of loci, acronyms, and initializations. There are tons and tons of these, but what I've decided to do is pick a couple of my favorites on the next slide here, and I go into these in a little bit more detail. And so we can start with our simple mnemonics, and these are the idea of using chunking and a hierarchy technique, and that's going to line up fairly well with what we've already talked about. When we were mentioning our sort of immediate memory, when we're talking about remembering our little grocery list, we were using chunking and talking about making connections to other things. So that actually applies for long-term remembering as well. So when we talked about chunking, we mentioned that it's just combining items into larger units that have meaning. And we're going to find over and over again that by introducing meaning, by making connections with other systems, by having more things, we're going to see better and better recall. So these are kind of keywords that are going to continually pop up throughout the lecture today and the rest of the chapter. But if we had a list and there's 10 words on the list, and 3 of those words are colors, and 3 of those words are animals, and then the remaining are items, then while you're trying to recall the list, you might say, okay, well, what were the colors? What were the animals? What were the items? And it helps you sort of fill in those slots, as opposed to if you were just trying to remember all 10 on their own, it would be harder. But if you can include chunking, it makes the process easier. And then with hierarchies, if you can organize items based on how they are related to one another, specifically if you can have some kind of order to them, it helps you remember that information better. And we actually do this with addresses. When you give someone your address, you give the house number, and then the street name, and then the town, and then the country. So all of this information has a set order in which it occurs, starting small with the specific house, and then getting larger, so from the house to the street, to the city, to the country, and having that sort of organization, having that meaning, gives us a framework in which to interpret that information. So we enhance our memory, again, due to associations and knowing there's that hierarchical relationship between the information. And we're going to see a bunch of these little graphs that talk very briefly about studies that have been done, because these kinds of word recall studies have been done pretty much in every way, shape, and form you can imagine. But here they had individuals who were given words to recall, again, lists of words, and they were either the words that could be put into a meaningful hierarchy, or the participants were asked to create some kind of random hierarchy. So meaningful hierarchy would be, well, maybe you remember all of the small things together, and all of the medium-sized things together, and all of the large things together. Whereas a random hierarchy would be like, oh, well, maybe you remember the blue things, and maybe you remember the things that are dog species or whatever, something that doesn't have meaning to it. And we see that performance is much, much better when we can have a meaningful hierarchy, a meaningful way to organize that information. So next we get into our visual-based mnemonics, and this is possibly my favorite diagram to include for any of our lectures. This actually came out of a textbook, and they were trying to explain the fact that when you visualize something, if you can make that image more intensive, if you can make it stand out more, if you can make it more memorable, it's easier to recall. And so they talked about the idea of interacting. So if you're trying to remember your grocery list, if you can remember the items on that list working together or connected with one another, it actually makes it easier to remember them as a whole because you've kind of interconnected them. And then the bizarreness, by having them be very strange, that makes it stand out more in your mind. So if you can have them be interacting and extra weird, then it's going to be a lot easier to recall because now they're very tangible, they're very standing out in your mind. But I have no idea who put together this diagram, but I thought it was great, and I use it every year for that very reason. And the weirdness of the diagram might actually help you remember visual mnemonics. But our next are semantic mnemonics, and we've already talked about semantics as things associated with meaning. So here we have some very commonly used ones. The first letter technique. If you've ever had to remember the order of the colors of the spectrum, you've probably heard Roy G. Biv, and you would remember that it's red, orange, yellow, green, blue, indigo, and then violet. So by knowing the first letter of each word, it helps you keep them in the right order. It also helps you remember how many you should know and which ones, because the first letter will kind of lead you to the correct one. We might also have a narrative technique. So maybe you tell a story and you can kind of blend the lines between the two. And I remember there's a full sentence to help remember the order of the planets. I've had some issues though, because I had first learned it as so like my very proud or my very something mother did this thing, but we had to change it because Pluto was dropped as a planet, so our sentence sort of stopped and we had to come up with a new one. And the fact that I now have two competing things has led me to not be able to remember either. But that could be a narrative technique by having a whole story that goes along with it. Or even when I was talking before about remembering our grocery list and saying that I want eggs and milk to make a cake, and then I want to make toast in the morning, that's a bit of a narrative itself, because we're assigning order. So we're using multiple systems again and helping us remember this information. And then our next mnemonic is the complex mnemonics. And this is basically just saying this is sort of the weird category where there's only one thing here. And this is the method of loci. And I found it very difficult to conceptualize this idea for quite a long time until the BBC's version of Sherlock came out a few years ago. And in that, Sherlock uses his mind palace. And that is the perfect visualization of this. So I've been telling students, if you have a moment and if it doesn't quite click, just Google the scene where he explains his mind palace. And that's the method of loci. But if you're not familiar with the show, this is when you link the things that you need to remember with a place that you are very familiar with. And this can be a real place or a made-up place. I use this for making a grocery list. So when I'm thinking about what I need on my grocery list, I actually sort of mentally walk around my own apartment. So I stop at the fridge and I say, okay, what do I need from the fridge? Well, I need eggs and milk. That goes in the fridge. Well, then I'll walk next to the fridge and there's a counter space where I leave my bread and fruits. Do I need bread or any kinds of fruits? How about the pantry? Is there anything in the pantry that I need to replace? And so when I'm making my list, I'm sort of mentally walking through my own home, and it's helping me sort of cue what I need in each of those locations. And then at the grocery store, I can walk through it again and think, okay, have I gotten everything from all of those places? So some people will use the method of loci for much more complicated and less direct things. So if you've ever seen people who apparently they professionally remember the order of playing cards, there's competitions where people will be given a certain amount of time and they have to memorize the 52 cards in the correct order. I have no idea why they want to do that, but a lot of them use a mind palace to do so. And they actually tell a story where each card has an associated character and they're in different locations in the house. And so they remember the order by walking through their house and interacting with those characters, and that associates with whatever card it is they're doing. That seems like a whole lot of extra work, so I've never really used it for anything beyond grocery lists, but it is something that a lot of people use. So an interesting one. And then our last memory enhancing technique is actually a nice way to bridge the gap between encoding information and retrieving information, because this is the idea that we encode information better if we periodically retrieve it. So the process of retrieval practice is basically saying that if we repeatedly retrieve information from our memory, it's going to be a lot more useful in storing that long-term memory so that we can use it in the future. And the way that I try and visualize this is if we imagine each single piece of information that we're trying to remember as, say, a location in our brain. And each time we go and get that information, we walk a particular pathway. So each time we walk along that path, we're going to be sort of stamping in the neurons that fire in the process of retrieving that information. So each time they fire, that association gets stronger. So the path gets more well-trodden. And over time, eventually that's a very well-traveled path, and it's very difficult for it to erode. So the more we access that information, the better we know it. And that kind of makes sense. If there's something that you use every day of your life, it's going to take you a really long time to forget it. So I have stuff like this where when I was much younger, I worked in a greenhouse. And because all of the plants were being watered all the time, you couldn't have barcodes on anything. So you had to remember 4-digit codes for each type of plant. And for probably a decade after that, I still knew which was the code for geraniums because I sold so many geraniums that year. It has since, fortunately, left my mind, but it stuck around for a lot longer than I ever thought it would. So that's this retrieval practice. And then we actually have a diagram here of an experiment that they did that tested this. And so the setup here is they had students who were either given the option of rereading their notes, so just read through them from beginning to end over a set period of time, or they could read and then test themselves on that information. And so the idea here is if you read it and test yourself, you're sort of putting that information away, pulling it back out to answer the questions, and then putting it away again. And then on the graph, we have along the bottom our retention intervals. So were they tested on that information 5 minutes later, 2 days later, or a week later? And then they have just the proportion of correct recall. So how well did they do? And in our 5 minutes, we see that whether they just read the information or read and tested themselves at 5 minutes, those are about the same. And this is where I always get mad that textbooks don't include error bars. I would anticipate that the error bars for those two line up completely, so there's no difference between those. And then at the 2 days and at the 1 week, we start seeing the yellow bar get much higher. So if the students were using that information more, their performance was much better, especially over longer periods of time. So that just tells us that as we use that information more, it's going to have a better persistence. It's going to stick around longer. And that's pretty effective. All right. And so the next thing I want to do is talk about retrieval. So it's kind of this blurred line where between storing and retrieving information, we tend to go back and forth quite a bit. And even that retrieval practice where we're putting stuff away and taking it out and putting it away again, it's a lot of back and forth between encoding and retrieval. And that's just how memory is. We pull information out of storage and put it back into storage when we're done fairly frequently. But we're going to focus in more on that retrieval process now that we've discussed how we store it to begin with. But retrieval is just our process of transferring information from our long-term memory back into our working or our immediate memory. So taking stuff out of storage and bringing it back into our conscious awareness so that we can do something with it. And we actually find that most of our failures of memory are actually failures to retrieve. So when you're trying to remember something and you swear that you should know the answer, it's usually because you can't find that information. So if it was a failure to encode, then there's nothing that could ever get you access to that information again. But if it's a failure to retrieve, then we're just saying that the information is still there, but you can't find the path to get to it. And we're actually going to find on the next couple of slides some of the tricks that make it easier for us to find that information in the future. And that's actually why we think that most of these failures are failures to retrieve, because if we can cue you or give you hints, you can usually remember that information. So it tells us that most of our sort of non-rememberings are actually just not knowing where to go and find the information. And so, of course, we can talk about cues, and these are just stimuli that lead to the activation of information that's stored in our long-term memory. I like to think of them as little hints. And as per usual, when we're looking at memory, more is going to be better. The more hints that you get, the more cues you have, the more likely you are to retrieve that particular piece of information. It's almost like a road sign that points you to the right pathway in your brain. And so by having these multiple cues, multiple hints, it starts sending you off in the right area to find that information. And it's going to get deeper processing. It's going to make you think of other concepts closely related, and then hopefully get you to the right answer. And we find that self-generated cues are usually a lot better than those that are generated by others. And this kind of makes sense. You know yourself a lot better than someone else does. So if you want to give yourself a hint, you're going to give yourself information that's actually useful in retrieving that information in the future. It's going to have some kind of personal meaning. And I've been using the example of if you're playing something like Pictionary, if you play with someone who you're close friends with, or maybe a sibling, someone you've lived with for a really long time, you do very well because you know how their mind works and you can provide hints and cues that work really well for them. But if you're stuck playing with someone who you've never met before, you might struggle to connect because you're providing hints and they're just not working. So you can think of that as the more familiar you are with that individual, the better the hints you can provide. So your own hints to yourself are going to be much more effective than those provided by anyone else. And in a couple of slides, there's a graph that actually shows an experiment that tested this, but it also incorporates another idea, so we'll get to it a little later. The next concept is priming, and this is a really cool one that we're going to come back to a little bit when we discuss how information is stored, when we talk about sort of our network of representations in our mind. But the idea of priming is basically like we are pre-exposing our brain to an idea. So if you think of priming a canvas, you're getting that ready to be worked on. Priming an engine is getting it ready to be started. So you're doing something to get your brain ready to have a particular response. So in a priming task, you're typically going to be pre-exposed to a piece of information. So of course, it's memory, so we're looking at lists of words. So this memory task would involve 2 steps. The first step is that you're shown a list of words. Maybe they ask you to read the list out loud, or maybe they do something like structural processing. Are they in all capitals or whatever? And so on that list, out of the, say, 100 words, one of them is the word store. And you don't have to do anything with this list. They don't even have to test your ability to remember that. All we care is that you for sure read that item and have somehow processed the fact that it was there. If in the second task, they then show you sort of a fill-in-the-blank question, and maybe they say, okay, STO blank, what word would fill this blank properly? People are a lot more likely to respond with store, which they had been primed to say, having seen it on the previous list, than they would be to fill it in with other letters, like stork or stop. So they're a lot more likely to use something that was most recently activated because those pathways in the brain were already warmed up and ready to be used. So this is kind of the idea where if we see things recently, it makes us a lot more likely to sort of think of it again. And this is what advertising kind of ties into, in addition to that familiarity makes you enjoy things more, but also if you see things very recently, maybe you see a commercial and it has a particular brand, maybe that makes you more likely to want that brand in the future because it's already sort of primed in your mind. I use the example of maybe you don't have a preference between Coke and Pepsi. You just know that you want a cola. But if you've seen an advertisement for Pepsi recently, then maybe that's what you want. So priming just sets our mind up to make certain decisions, certain pathways easier to navigate because they've been recently activated. Okay. And then this is the diagram I was talking about. So this is looking at memory retrieval. And this is kind of frustrating because this graph is pivoted from what we usually see. So usually we have our sort of performance on the y-axis, and then the x-axis are our different categories. This is the exact opposite. So now we have percent remembered on the x, and then our different conditions on the y, just because they wanted to write more, but it's just weird to have it set up that way. But what we have here is at the top, we have an individual who they were given a list of words and they were asked to create cues or hints for themselves to remember those words. So during the learning, they were given that sort of make these cues. How did you do? During learning, the next group was, okay, so you're going to make cues, but they're for someone else. You're using someone else's cues. How did you do? And then the last one is they didn't have that cue creation. So they just tried to remember the list as is. And so this is giving us, okay, it's much, much better to have cues than it is to not have cues. But if you do have cues, making your own is a lot better than using someone else's. So this kind of ties together a bunch of different concepts where more and more personal and more in-depth is going to be better for learning. Okay, and then our last section here is actually going to be a bunch of different ways of saying the exact same thing. So here we're going to talk about matching retrieval conditions. And so this is basically saying that we want the conditions that we use at encoding, so when we're studying, when we're learning something, we want those conditions to be as similar to our recall conditions as possible. We want there to be as much matching as possible. And you've probably heard this before. When you're studying for a test, you want to study in the same room, at the same time of day, and all of those things. Where if you can match your study conditions to your testing conditions, you're going to perform a lot better. And this applies on so many different levels. So we're going to pick a couple of examples because, again, these studies have been conducted from all different angles. So we're just going to pick a couple of strange ones that are funny to look at. But we're going to sort of break it down into 3 specific ways to achieve matching. So we're going to look at encoding specificity, we're going to look at state-dependent learning, and then we're going to look at transfer-appropriate processing, and examples for each of these to follow. So for our encoding specificity, we're saying that when we're learning information, so when we're studying, we are going to be associating that information with the context in which it was learned. So it should be beneficial to then also be tested in the context in which it was learned. That's why I really like having tests in the same room as the class is held, because you learned that stuff here, it's better to test you for it here. And so this was a study done in the 70s. It's a really weird one, but they had individuals who were given, again, long lists of words, and they were specifically using scuba divers. And so some of them were taught these words while scuba diving, so underwater. And the rest of them were taught while sitting on the side of the pool on the land. And so, okay, you have one group that's learning underwater, one group that's learning on land. What happens if they are tested either in water or on the land? And this is another strange diagram, but they're all going to start looking the same. We don't have anything labeled on the x-axis because we're actually just going to follow down from the top. So the leftmost bar, that orange bar, is students that were studying underwater and were tested underwater. And then we have our performance on the y-axis, which is as per usual. And so we see that that bar is quite high. They did fairly well if they studied and were tested both underwater. But performance drops if they studied underwater and were tested on land. And then the cool part, because they wanted to make sure that it's not just that being underwater or not underwater was sort of better or worse, they did the opposite. So if they were on land while they were studying, what happens if they were tested on land or tested in the water? And so the color coding here, the orange ones, the higher bars, are when the study and the retrieval conditions match. And then the blue ones, the shorter ones in the middle, are when they don't match. And it doesn't matter if you learned underwater or on land. What matters is if the contexts are the same, if you're retrieving that information in the same context as you were when you learned it. And we can look at a different example of this. They did the same basic setup 20 years later, but they were looking at students studying for a test, and they studied either in noisy conditions or quiet conditions, and then were tested in either noisy or quiet. And we see the exact same setup here, where the orange on the outside, where it matches, they do better. Blue on the inside, where they don't match, they do worse. So we're seeing, again, matching is going to be better. And we're going to keep looking at this matching is better, the same is better. And this is state-dependent learning. So this says that learning is also going to be associated not just with our external context, but our internal context. So what is our internal state? Are we highly caffeinated while studying? If so, we should try and be highly caffeinated while testing. That's why sometimes you might have similar thoughts while you're tired. And then the next day, you can only remember that when you're tired again. So you're matching those internal states. So mood is another example of this, level of tiredness, physical fatigue, presence or absence of different substances in your system. The more you can match, the better you're going to do. And so we can have another one of these diagrams. This time they've swapped it out with mood. So did people recall a sad or a happy memory before studying? And did they recall a sad or a happy memory before testing? And again, matching is going to lead to better performance in both cases. And so there are hundreds and hundreds of these types of studies. And the big take home is if you can match them, you're going to do better. And then the last one I want to talk about is sort of the same basic idea, but now we're talking about sort of the process itself. So this is transfer appropriate processing. And this is basically saying that you do better, you perform better in these memory tasks if the type of task at encoding matches the type of task at retrieval. Are you studying the information in a way that is similar to what you're going to need to remember it for? And I like to use this example when studying for an exam. When I was an undergrad, I was in a bio degree. I had to do a lot of memorization. A lot of my tests were based on recognition because I was doing multiple choice tests, and I had to know this definition goes with this term, and this term goes with this definition. So I switched up my study style, and in those classes, I used cue cards. I still have shoe boxes full of cue cards at home under my parents' storage unit. And so on one side is a definition, and on the other side is the term that goes with it. And I would study for those classes, for those multiple choice recognition tests, using those cue cards. That's one of the reasons why I focus so much on telling you guys that I test understanding. And a good way to study is to try and explain a process to someone else, or to try and think about different examples that work with it. Because a lot of students like to study with straight recognition, but it doesn't carry over as well. Their performance isn't as well if it's being tested in a different way. And so here they've looked at, again, words, lists of words, and they got you to encode by either asking you about the meaning of the word or by asking you if the word rhymed with something else. And then during retrieval, both groups were then tested with a rhyming recognition task. And the ones that had learned with rhyming did better than those who had learned with meaning. And that even goes against the fact that when we focus on meaning, on semantic processing, we tend to remember things better. So just by having a match between the encoding and retrieval, that was sufficient to overcome the benefits of deeper processing. So sort of a double whammy there. And they've done, again, lots and lots of these. This is from the 70s, so they've done many iterations since then. But all of this is telling us that the more that you can match, the more that's consistent between your studying conditions and your testing conditions, the better your performance tends to be. Okay, and that was everything I wanted to cover today. Like I said, we're going to do forgetting and the rest of retrieval on Friday, but we should be well on track to finish up this chapter Friday afternoon.